Step number 1, vertical asymptotes holes. Factor everything. If a binomial cancels, it's a whole. Factor everything. If a binomial cancels, it's a whole. Calculate the y value of the whole. Calculate the y value of the whole by substituting x calculate the y value of the whole by substituting x into the, grabbing my red pen, factored form of the equation. Factor everything. If the binomial cancels, it's a whole. Calculate the y value of the whole by substituting x into the factored form of the equation. If the binomial does not cancel, it is a vertical asymptote. If the binomial does not cancel, it's a vertical asymptote. Five. Do you think I would make a box where they didn't fit? Using the number of vertical asymptotes. Using the number of vertical asymptotes, picture the shape of the graph. Using the number of vertical asymptotes, picture the shape of the graph. For horizontal or oblique asymptotes, analyze the degrees. Analyze the degrees and decide on case 1, 2, or 3. Analyze the degrees and decide on case 1, 2, or 3. Am I going too fast? Step number 2, calculate the x and y intercepts. Calculate the x and y intercepts. Calculate the x and y intercepts. And the last step, when necessary, used test points. When necessary, use test points to determine the shape of the graph. And I'll explain that when we do the first example. Maybe the second, can't remember. For the first example, I'm going to number the steps. So step 1 is vertical asymptotes or holes. This is where we factor anything that we can. Can we factor the numerator? Yep, it's the same example we did this morning. Can we factor the bottom? No. Conclusion? Vertical asymptote. X cannot be 4. Agree? Let's draw it as we go along. So we'll do a step draw and then do a step draw. I've talked a little bit about exam panic, and I'm going to talk about it as we get closer to the exam. Exam panic is when you're writing the exam and suddenly your brain goes completely blank. Right? We've all been there at some point. And then you call me over and you ask me the most ridiculous questions, but I can't laugh because you're in exam panic and I feel bad for you. Last year somebody called me over. Miss Johnson, I can't remember anything. I can't remember. Is a vertical asymptote vertical or horizontal? Vertical asymptote? Vertical. Okay, so we draw them vertically. So go where x equals 4. Remember, they're dotted, they're red, they're not pink, they're not orange, they're not blue with a note, this is red, they are red. They're always red. On the provincial exam, that is typically 1 mark. So even if you can do nothing else, if you can get the vertical asymptote and graph it, you're going to get 1 mark on this question. Step number 2 is your horizontal or oblique. This is where we look at the degree, so what we did this morning. Degree on the top is 1, degree on the bottom is, so that's degree over degree. Case 1, 2, or 3. Case 2, this is where we look at the leading coefficients. Leading coefficient on the top is 2. Leading coefficient on the bottom is imaginary 1. So our horizontal asymptote is that y cannot be 2. Horizontal asymptotes are, get this, horizontal. I know. So I'm going to go where y equals 2. I totally skipped step 2. This is step 3. Let's just pretend I did step 2 and we'll come back to it. Step 2 was once you know how many asymptotes, picture the shape. So because this is a 1 vertical asymptote graph, picture the shape. What does it have to look like? So it either is a volcano where both the pieces are on the top, or it's where 1 is on the top and 1 is on the bottom. I don't normally write anything for step 2. You just want to put the shape in your head so that it makes it easier to draw once you get to the final step. So picturing the shape just comes from the number of vertical asymptotes. Again, I would not normally draw this. I'm just showing for you the thought process for step 2. Okay, step 3 we've done. We've got our asymptotes. Step 4 is our intercepts. Y-intercept, we make everything with x equal to 0, so just ignore everything with a 0. What is left on the top? What's left on the bottom? Can we reduce it? Equals? And again, just like we talked about this morning, I like to put this as a point so that I remind myself it's a point on the graph. It's not a vertical asymptote, horizontal asymptote, any kind of asymptote. It's an actual point. So 0, negative 1/2. I'm going to do my dot really big so you can see where I've done it. I wouldn't normally take up the whole space, but I'm just showing you it's 0 left to right, a half unit down. Y-intercept, 0 for y. We can ignore the bottom, y, because when you multiply it over, it cancels with 0, so all we have to solve is for the numerator. How do I get rid of plus 2? How do we get rid of a coefficient? Divide by 2, x equals. And so this is the point, negative 1 is 0. So what that did is give me this part of the volcano. I know it's got to approach the horizontal asymptote, it's got to pass through those two intercepts, and it's got to approach the vertical asymptote. That side we're A-OK on. So if I had the bottom, x minus 4, the first thing would do is to multiply by it to get rid of it. When you multiply 0 by x minus 4, what happens? It becomes 0. So I got half my volcano. The problem is now I don't know where the other half is. I don't know if it's down here. I don't know if it's up here. I know it's not in this quadrant. How do I know it's not in this quadrant? Because I only have one y-intercept, and it's not up here. So I don't know where it is here. It could be the top, it could be the bottom. This is step number 5. When you get to this, if the intercepts don't help you, you need to pick a test point. I need any point in here. I could put x equal to 5, x equal to 6, x equal to 10, x equal to 100, x equal to 6.72, x equal to 9.7. It doesn't matter. Pick an x value somewhere in here. Give me a value. 8. And I'm going to just make a note. This is called a test point. It didn't have to be 8. It could have been 5, 6, 7, anything in that area that's just going to tell us where the value is. What I need to know is what's the y value of 8? Is it above the horizontal asymptote or is it below? How do I find the y point for any point? Substitute into the equation. So on the top, I have 2 times 8 plus 2. And on the bottom, I have 8 minus 4. Can I reduce 18 on 4? And I'm probably going to want to put this in decimal because we typically count points by decimal. So what's 9.5 as a decimal? And again, I'm just going to write this as a coordinate point just to remind us that's what we've calculated. We've calculated the point 8, 4.5. What was the purpose of doing that last calculation? To find out where the other piece of the volcano is. So I'm going to go to 8, and I know it's up here at 4.5. That tells me the other piece of the volcano has to be in the top right section. So I'm just going to fill it in by approaching those two axes, or the two asymptotes. That's all step 5 means. If you're not sure of something, pick a point, sub it in, plot it. That's where the other part of the graph has to be. Like, this is impressive math. Like, look how smart you are being able to do these by hand without a graphing calculator. It's like, this is smart stuff. Same steps every time. We're just going to practice the different kinds. So we're going to do some sad clown faces, some volcanoes, some oblique stuff. Good stuff going on. Vertical asymptotes are holes. What do we do? Okay. I think I already heard somebody say x plus 3x minus 4. Now look at that bottom. We actually talked about this example yesterday. That bottom's like, it kind of looks like it's going to cancel, but it's not quite going to cancel. So what are we going to factor out a -1 to force it to cancel? X minus 4. So we actually don't have a vertical asymptote. We actually have a hole at x equals 4. Now I'm going to actually cancel this, and I'm going to simplify it up because it's going to make our calculation easier. So I'm just going to put that negative to the front, and then I had that x plus 3 on the top. And I don't really want these brackets, so what can I do with the negative? Just distribute it through. So negative times x is negative x, and negative times positive 3, negative 3. Highlight this, circle this, put some glitter on it. This is the factored form we're going to keep coming back to. If you go back to the question, everything's going to fall apart from here on in. Go back to the factored form. Wait, what?
With the canceling thing.
Yes?
Wasn't that already x minus 2? Or minus 4, I mean?
No, it was 4 minus x.
Oh, okay.
We're good?
Yeah.
Okay, I need to find the y coordinate of the whole, so I go back to the factored form. I'm going to stick in that x, so we have minus 4 minus 3. Minus 4 minus 3 is? So we write this as a coordinate pair. And because I'm left-brained, I put a little hole in front of it, just to remind me that's a hole that's going to be in the middle of the graph. How are we feeling on step 1? This is our first graph with hole. Yes, sir? I went back to the factored form, and I just subbed in 4 for x. And then just simplified it. Okay, step 2, horizontal or oblique asymptotes. Always go back to the factored form. Always go back to the factored form. What do I do with this? Well, it's degree over nothing. This is degree over nothing. What do we do? Well, look at this. What kind of graph is this? It's just a line, so this doesn't have horizontal or oblique asymptotes. They're gone because we canceled the bottom. So they're irrelevant in this case.
So whenever you have holes, because you'll cancel the bottom, you don't have it.
Yes and no, because sometimes there's 2 binomials on the bottom, and you'll cancel 1, but 1 will be a vertical asymptote, so it will still be there. So yes and no, depending on the question. Okay, but if you get something like this, it means there's no horizontal asymptote. Go on to the next thing. Y-intercept. It's a line, so you can actually just tell the y-intercept by covering up the x. Y-intercept has to be. So 0, negative 3 is our y-intercept. X-intercept, so 0 on the left. Ooh, somebody's already quick. Everybody okay where the negative 3 came from? Okay, so I'm going to put the hole first. So I'm going to go to 4, negative 7. And all I'm going to do is put a little hole there. So far, that's how I graph the hole. Just put a hole in the middle of the graph. I'm going to plot the y-intercept, so 0, negative 3. I'm going to plot the x-intercept at negative 3, 0. And then what am I going to do? If these don't form a line, you've done something wrong. There's your very first graph with hole. Sorry? No red pen because there's no asymptotes. I know. Again, I'm going to repeat. You might want to make a note. If these don't form a line in a situation like this, you've done something wrong. And it's usually you forgot to calculate the y coordinate of the hole. Because some people will want to just put it at 4, 0 for some reason. But that wouldn't make a line. So it has to make a line because you know that this is a linear function. Better? Holes aren't bad, eh? That's not bad. It's kind of pretty. Question didn't ask, but let's talk about it. What would the domain of this function be? XER, except x cannot be where the hole is. So we'd write it as XER, comma, X is not equal to 4. That's what we'd write the domain. Everything except the hole. Okay, vertical asymptotes are holes. You see how it's the same steps every single time? See that? Can we factor the top? No. Can we maybe factor the bottom? The range would be the same, so it would be YER, Y is not -7. Good question. Ooh. Got an offer of x plus 4, x minus 2. Do they cancel? Conclusion? Oh, 2 vertical asymptotes. Cool. What kind of graph? So you know right away you're picturing something that looks like sad clown face. That's step 2, is just put the graph in your head, so when you go to draw it, you have that idea. It's got to be some kind of sad clown face graph.
Shouldn't it say x is not equal to 2 instead of x is equal to 2?
Good catch. Horizontal or oblique asymptotes?
Because you can't say x is equal to an asymptote.
Correct.
Similar to how you can take the square root of
Justine may kill you, just saying. You can't see your face, but I can. Okay, degree on the top. Degree on the bottom. What situation do we call that? Okay, case 2. Is everybody okay where the 1 came from? Turn and talk to someone around you, tell them why. It's y cannot be equal to 1. Y-intercept. Y-intercept. Put 0 so everywhere you see x, what does the top become? What does the bottom become? What's 0 divided by -8?
Shouldn't it be -0 divided by negative?
How about you put in negative and I'll just put an imaginary negative. X-intercepts. Ignore the bottom, just look at the top. Turn and talk, tell your partner why do we ignore the bottom? You're less excited about that turn and talk. How do I get rid of a squared? Square root. That's not a surprise because we actually already had it up here.
So we didn't really need to.
We didn't really need to do it.
We knew that.
So if the y-intercept is the origin, the x-intercept is the origin. But that was kind of fun to practice. Okay, let's draw your vertical asymptotes. They are drawn vertically. But then that would just get Andrew going, so I was, trying not to go there. And thanks for that, though. So -4, we got a vertical asymptote. And 2, we got a vertical asymptote. Horizontal asymptote at y equal to 1. And we have a point at the origin. Not a lot to go on here. Well, we don't know. We don't know if it's parabola or cubic because we have both now. Are the eyes on the top or the eyes on the bottom? We don't know. How do you know? But if this was a cubic, they could be here. So what do we need to do? Okay, so let's start on this side. Give me a test point. -6. On the top, I'm going to have -6 squared. On the bottom, it's going to start with another -6 squared, so 36, plus 2 times -6. And then I got that -8 hanging around. So 36 on the top. If I put the negatives together, -12, -8, -20, 36 minus 20, 16. Can I reduce those? By what? Can I do more than 2? 4. Okay, reduce them by 4. And again, we usually like decimal values when we're graphing. So divide 4 into 9, 9 into 4. Trying to squish it in there. So -6, 2.25. Put it away. Put it away. So I know the I on this side is going to approach the asymptote, go through that point, and approach the other asymptote. Yeah, well, if I know if the left eye is on the top, the right eye is going to be on the top too, because they're always on the same. So we could do the work, or we could just use some estimation. If I see the distance here, it's going to be roughly the same distance here. So just sketch in the eye. It's got to be roughly the same. That's the way they work. The eyes are always together. They're both on the top or both on the bottom. They're never opposite. It's the middle piece. We don't know, is it a parabola or is it a cubic? We don't know. Okay, test point. Give me a point in here. Well, we can't do that because that's an intercept, so it's going to give us this. -2. I like it. So on the top, we're going to have -2 squared, which is 4. Thank you for that. On the bottom, it's also going to be 4. I'm just writing down what you guys are saying, so you might want to double check these. Confirm, not confirm? I just wrote down what you said. If you don't like it, fix it.
It's pretty confusing me because I'm not sure if you're just saying it because we're confused or we're just...
And again, I'm drawing it really, really big. I normally wouldn't take up the whole square. So what does that tell you about the left-hand side in the middle here? It's got to go down towards the asymptote because the test point is lower than the intercept was. But what about here, though? Does it come back down like a parabola? Does it swoop up like a cubic? Test point. Is it a parabola or is it a cubic? It's a parabola. Sad clown face.
We can probably tell just by the equation that it's a parabola.
How do you know?
Because it's...
Oh, cubics will look the same in the middle, though, because it's actually a half parabola that's been flipped up. That's how the cubic comes about. This is as hard as they get, by the way. This is like a 5-mark question. Like, this is like hard. Okay, we've done volcano, we've done graph with hole, we've done sound clown face. What might be coming up next? Something pretty cool. Go ahead with a friend, find me the horizontal, or sorry, the vertical or the vertical asymptotes or the holes. So factor your little hearts outside which one it is. I'll do attendance since I forgot.